One example of greedy algorithm is Ford-Fulkerson algorithm for max flow. It is used to find the maximum flow from the single source S to a single sink T. So we want to determine the capacity of a certain network that will determine the flow of data or of something from the source going to the sink. Okay? So one application of this algorithm could be in road network, wherein we want to determine the number of vehicles that could pass through to this network. Another example is water flow in pipe. We want to determine the volume of water that could pass through this pipe network. So how could we determine if we could implement this algorithm? So first, we need to have a flow network, which we call G. So it is a simple directed graph. It means there is a direction, the flow, there is a direction from one node to another node. And there should be one source, which is S, and one sink, which is T. So if you say source, it is the start node. Sink means the end node. And the capacity of edges should be positive, non-negative. Okay? Always positive. So after determining that we could implement our algorithm in a graph, so now we're going to create a residual graph or GF. So we are determining the residual capacity of the given graph. Okay, if say residual capacity, so if we take a certain path, so what will be the capacity left for the next, for the other flow, for the other path? Okay, so basically the formula for residual capacity will be capacity minus the flow used. Okay, and if there is a residual capacity, so we need to have a reverse edge wherein it gives us an idea. This is how much we use in the capacity of that edge. So usually the direction of it will be from end to start. Okay? So reverse edge means different direction from the usual or from the direction given by the problem. Okay? So later we're going to discuss what is reverse edge, what is residual capacity when I discuss an example. Okay? And to help us in our analysis, we need to do augmenting path. Determine the different path and determine what will be the capacity usage for each path. Okay, so the smallest capacity in the path P will be considered as your residual capacity for the whole analysis. Okay, so what are the steps? Find an augmenting path. Find a path that will connect the start and end node. Then second, compute the bottleneck capacity or determine the minimum edge that will have an effect on the flow of our data of our water or our vehicle. Okay, why minimum? Because this will be what the location of the bottleneck. Okay, and then third, augment edge and total flow. Add everything. Okay, so that we could know what is the capacity left for the other path. Okay, and fourth, find the backward path or backward edge. Okay, that will, and again this will show the used capacity. Okay, so let's have this example. We have 6 node S A C B D T. The source is S node and the sink node is T. And we have different capacity here for different edges. And by the way, the notation for the value that we could read here is flow versus capacity. Flow used on a certain path and the capacity of that edge. So if this is 0, it means this edge is not yet used by any path. But if there is a value, for example, it's 2, it means 2 of out of 10 is used or was used on a certain path going to T. Okay? So now, so first step, find the path from source S going to sink T. So we have different ways, different paths in reaching T. So just choose one. So for me, so we have two options from S, either going up or going down. So I'm going to choose the up, going to A. So S, A, and then I have two options, going to D, going to B. So I'm going to use or going to choose B, then T. So this will be my first path for my first analysis. Now, second step, compute the bottleneck capacity. Which edge has the minimum value or minimum capacity? So this will be the bottleneck. So it's 4. Therefore, when we choose this path, the maximum value that will flow is just 4. So 4 out of 10 will be used here, and also 4 out of 10 will be used from B to T. Okay, so that will be our first path. So third step, that's it. Fourth step, create a reverse edge that will show the used capacity. Okay, so again, it's just for equilibrium. Okay, choose another path. So now I'm going to consider the SCDT path. Okay, so now what is the bottleneck edge? It's 9. That's the smallest value on this path. So it means 9 out of 9. I already used the capacity of this. So no one could pass on this node or this edge rather. And 9 out of 10 is used from S to C and D to T, same as 9 out of 10. Okay? So after determining the capacity, so now let's create or let's determine the reverse edge. So since out of 10, 9 is used. So we have a reverse edge here, 9, same as here, 9, and 9 here. Okay, so we still have one here, one capacity here not used between S and C. So let's look for a path for this capacity. So from S to C, is there any path going to T? None. Am I right? Because we cannot choose C to D since all capacity are used. So there's no path going to T through C. So we cannot choose this capacity, the last one capacity from S to C. Okay, so let's consider S to A. So we still have 6 unused. So let's look for a path. So we have two options from A. So going to C or going to D. So let's check. If I'm going to go to C, is there a path going to T? Definitely none, since again, C and D is already used. Capacity full. So we cannot transfer any data from A to C. So therefore, don't choose this. So now, definitely, we're going to choose D. So A to D. So now we're in D. We have two options, going to B or going to T. You may go to T so that we could use this last capacity. But for me, it is better to go to B and then go to T. Why? Because as you can see, the unused capacity here is 6. And the bottleneck here is also 6, and here 6. So basically, most of the capacity of the path will be used from SADBT. So if we're going to use DT, still we're going to pass through SADBT. So why not just have one path? Okay, so that's why I'm going to choose SIDBT instead of SIDT. So again, the bottleneck is 6. So update everything. So now this is fully utilized, another fully utilized. And for this node, 6 out of 8 is used or was used. Okay, so after augmenting the edges and total flow, next will be create the reverse edge, just to show the different capacity used. Now, so it means everything is in order, everything is used. Okay, now we're going to determine the capacity now. So just look for the values going to our T, to our sink T, or just look at the residual or the reverse edge. Okay, it will give us an idea. This is the capacity of our network. So we have 10 and 9. Just add. So that will be the capacity that will flow from S to T through ABCD node. So unfortunately, it's not 20, only 19 because of the one unused. There's no path for it. Okay, so that's for the algorithm. So what is the time complexity? So finding an augmenting path. So our big O notation is E, and all of these steps is basically based on F, wherein F is the flow. So the time complexity is E times F, number of edges times the maximum flow. So if it's 19, so times 19 times the number of edges. That will be the time complexity. Okay, so that's it for this video lecture. See you on the next. Thank you for listening.